back to my channel. It's your boy Mentor the Great. If you're new here, ensure you hit on the subscription button and hit on the notification bell, and please share, comment, and like my video. Today I will be taking us on introduction to physics, and let's start with the definition. Physics is the branch of science that deals with the study of matter and how it is related to other physical quantities. Of course, when we talk about physical quantities, we'll talk about the mass, length, and time, which are the fundamental quantity. So if we say that physics is a branch of science that deals with the study of matter, we have to know the definition of matter for us to understand what physics is talking about. Matter is anything that has mass and occupy space. So when we say physics is the study of matter, for instance, the physics of motion has to do with a moving car. For instance, let's use a moving car as a case study. A moving car is a matter. Of course, it has mass and it occupies space. And there are some physical quantities associated to a moving vehicle, and the likes of velocity, acceleration, distance, displacement, time, mention them, and so on and so forth. So the study of a moving vehicle, which is a matter, and the quantities associated to it, being it fundamental quantity or derived quantity, then we are talking about physics. Then when we talk about projectile motion, let's use tennis as a case study. The tennis itself is a matter, and of course we talk about the angle of projection, we talk about the initial velocity and all of that. All these physical quantities has to do with that. In fact, there is nothing you can think of in physics that has nothing to do with, it must have something to do with mass and physical quantities. Okay, then what are these physical quantities we are talking about? Physical quantities are divided into two. We have the fundamental quantities and we have the derived quantities. So what are these fundamental quantities? Fundamental quantities are those basic quantities that are independent of other quantities. They can't be defined in terms of other quantities or being derived from them. They stood on their own and they make their own meaning. The fundamental quantities are the likes of mass, length, and time, basically. I was still going to give us other fundamental quantities, but for now, the first fundamental quantities as far as physics is concerned, of which is the bedrock of other fundamental quantities. They are the likes of mass, length, and time. Then let's talk about definition of mass. So mass is defined as the contents of matter or material substance. Mass is defined as the content of matter or material substance. Of course, it is measured in kilogram. Then we'll talk about the length. Length in its definition, it is the extent of space or the distance extended. Is the extent of space or distance extended, and it is measured in meters. So that's the SI unit of length is the meters. And then still you have to know that any quantity that is measured in meter is dimensioned in length. That's the length is the dimension of any other quantity that is measured in meter. Then when we get to dimension analysis, then you will understand that very well. Then let's talk about the next one, mass, length, and time. Of course, time is defined as that to which an event is distinguishable with reference to before or after. So when we talk about time, we talk about before, after event, and it is measured in seconds. That's the smallest unit of measurement of time is the seconds. Then the taking hand. All right. The next thing I want us to talk about, now, of course, we've seen the basic fundamental quantities, the likes of mass, length, and time. The next thing I want us to talk about now is other fundamental quantities. Let's see how we're going to get our one done. We have, let's keep it in tabular form. Let's do it in tabular form. Let's have a fundamental quantity. Fundamental quantity. Okay. Fundamental unit. Let's say, of course, the unit. That's the fundamental unit. And the symbol. Okay, when we talk of fundamental units, they are referred as the unit of the fundamental quantity. The unit of fundamental quantity is called fundamental unit. Of course, let's recap the first three fundamental quantity before we give you the other ones we have. We have the mass. As number one. Number one, we have the mass. We have, of course, the mass, the unit is the kilogram. And of course, the symbol for kilogram is kg. The next, we have the length. The length is meters. And the unit is m, a small letter m. Then we have third one, we have the time. Of course, the unit of time is the second, and then the small x. Then other fundamental quantities that we have the likes of temperature. We have temperature. And that's the unit is Kelvin. If Kelvin, that's K. Then there are other fundamental quantity. We have amount of substance. That's the unit is the mole. Then the symbol is mole with omission of letter E. That's the symbol. Then number 6. We have the electric current. We have the electric current, and the electric current is measured in ampere. That's the unit of electric current, the ampere. And then A is the symbol. Number 7, we have the magnetic flux. Of course, the unit is the Weber. That's the Weber. And of course, the symbol is WB. And the last but not the least is number 8. That is the luminous intensity. And that is measured in candela. And of course the unit is CD. So we have the fundamental quantities: the mass, the length, the time, the temperature, amount of substance, electric current, magnetic flux, and luminous intensity. Okay, before I go further before I end this video, the last part of this I want to talk about is the system of measuring mass, length, and time. Before we get to the derived quantity, so let's talk about the system of measuring mass, length, and time. That's the fundamental quantities. We have the first system of measuring mass, length, and time is what we call the System International Unit. We have the System International, that's the SI unit, and we have the standard unit. So the system international unit of mass, length, and time is the mass measured in kilogram, the length measured in meter, and time measured in seconds. So, but we arrange it from meter first, then we arrange it from meter, that's we have meter, kilogram, second. So this meter, kilogram, second is the measurement of system of measuring mass, length, mass, and time, and it is called the MKS system. That's MKS. The MKS is the system international unit of length, mass, and time. Then another system of measuring mass, length, and time, though this one is the most acceptable universal unit of mass, length, and time, is meter, kilogram, second. Then the alternative system of measuring length, mass, and time is the one we call centimeter. Centimeter, gram, second. Centimeter, gram, second. This one is the CGS. So we have two systems of measuring mass, length, and time. We have the MKX and we have the CGX. So, but the most accepted is the MKX, that is the SI unit. So, whenever you are asked the SI unit of mass, length, and time, you should boldly tell the examiner kilogram for mass, then meters for length, and then seconds for mass. Then this second one, this one is called the standard unit. This is the SI unit and this is the standard unit. So, the standard unit of length, mass, and time is the centimeter, gram, second. Then the next thing I will want us to look into is derived quantities. Of course, this is the second part of the quantities in physics. That's physical quantities in physics. So, derived quantities are those quantities that are gotten by the simple combination of one or more, two or more fundamental quantities. So if you want to get a derived quantity, you combine two or more fundamental quantities to get a derived quantity. So of course, the combination of length, dimensions of unit of length and breadth, because of course, when we talk about area is a derived quantity. So for you to get it, it has to do with the dimension of length and the unit of length and the unit of breadth. So when you are interested in getting the area of a given square field, or let's say the area of a rectangle, then one of the edge is the length and the other edge is the breadth. So multiplying the length by the breadth, you get the area. So area is derived by combining two units of length, and of course, the unit of area is the meter square, because the unit of breadth is the meter and the unit of length is the meter. So when multiplied together, you get meter square. Then when you talk about derived units are the units of derived quantities. They are still the units that are gotten by the simple combination of two or more fundamental units. You get a derived unit. So in tabular form, we're going to introduce some basic derived quantities, their derivative, that's how they are gotten, and the derived unit. So the first one we have is area. Area, the derivative is length multiplied by breadth. And of course, unit of length is the meter and unit of breadth is the meter. So meter multiplied by meter, the derived unit is meter square. Then we have the volume. The volume is the length times the breadth times height. Then the unit of length is meter, and that of breadth is meter, and that of height is also meter, because all those things explains length. Height is still the extent of space. breadth is still the extent of space, so everything is just the same thing as length. But simply because all these edges or sides are not equal, they are unequal. Therefore, we give them the name. This one we give them the name length, breadth, and height. But that doesn't change the meaning that it is still talking about length and should be measured in meters. So both the length, the breadth, and the height are measured in meter. So meter times meter times meter is going to give us meter cube. Then we have the density. Density is mass over volume. And of course, the unit of mass we all know from what we've talked about before, that the mass is measured in kilogram. Of course, the volume is already here, which is a meter cube. So kilogram over meter cube will be written as kilogram per meter cube, or sometimes in some case you see kilogram meter to power minus 3. So this is still kilogram per meter cube. Then we have the velocity is displacement over time. Then displacement is measured in meter. Time is measured in seconds. So meter divided by seconds will give us a derived unit of meter per seconds. Or in some case you will see it written meter seconds inverse. Let's raise to power minus 1. Then we have acceleration. Acceleration is velocity over time, and of course velocity is already here, which is meter per seconds per seconds. Just taking up the x, coming up to the numerator, picking up this x, taking it up to the numerator, we're going to have meter per second squared. It will double it in negative. Alright, we have the force. Force is mass times acceleration. Of course, the mass is kilogram and the acceleration is meter per second squared. So that we have the unit as kilogram meter per second squared. Of course, this kilogram meter per second squared is the same thing, or is equal to 1 Newton. Is equal to 1 Newton. 1 Newton is the SI unit of force. So instead of using kilogram meter per second square, we use 1 Newton as the SI unit of force. Then coming down to pressure. Pressure is force over area. By formula, the force is measured in Newton already, and area is measured in meter cube. So the symbol for Newton there is N. So that the derived unit there is Newton over meter cube. And of course, we can write Newton per meter cube, or we can write it this way: Newton meter exponent, or Newton meter raised to the power minus 2, not exponent, not exponent. So Newton meter raised to the power minus 2. So we have the last one here, momentum. Momentum is gotten by the product of mass and velocity. So velocity, mass is measured in kilogram. The velocity is measured in meter per seconds, so that the SI unit, that's the derived unit there, becomes kilogram meter per seconds. That's kilogram meter per second. So these are some of the basic derived quantities, their derivative, and their units. There are many more other fundamental derived quantities. There are many other derived quantities, but for now, this is what we come up with. Then subsequently, in my subsequent videos and topics, you will see we're going to expose some other derived quantities. So I will end this video here right now. Then the next topic we'll go into is the what do we call it? Dimension analysis. We're going to talk about dimension analysis. From there, we're going to elaborate more on other derived quantities that I didn't mention here. We're going to look into their dimensions. From there, we'll know their formula and how they are gotten. Thank you and have a nice day.